Hello friends, this video on NEET current electricity is brought to you by examfear.com. No more fear from exam.
Question number 19. An ammeter connected in the circuit as shown in the figure shows a reading of. So we have to find out the reading of the ammeter. So let us look at the circuit. So this is how the circuit looks like, and this is the reading that we need to find out. That means we basically need to find out the current that would flow through this circuit. Okay, so in order to find that out, we will first need to calculate the equivalent resistance of the circuit, because we have so many resistances, each of 2 ohms, right? So let us first try to simplify the circuit. Okay, so for that, what we can do is, instead of having this circuit, just imagine these 2 points, okay, and take this entire half of the circuit on the top. So in that case, how would your circuit be like? So your circuit would become somewhat like this. So let's name these points as A, B. So let's fix these points A, B here. Let's say this is A, this is B, and you have a resistance here, you have this cell here, and this is your ammeter. Okay. And now what we do is, here you already had 2 ohm, and now these entire part, we just flip it to the top. So you get one more 2 ohm here, and you also get another 2 ohm here. So each of these resistances are 2 ohms. Now if you want to, we want to calculate the equivalent resistance of the circuit. So very clearly we can see that these 3 resistances are in parallel. So we can calculate the equivalent resistance of these 3 resistance, which would be equal to 1 by R parallel is equal to 1 by R plus 1 by R plus 1 by R, which will be equal to 1 by 2 plus 1 by 2 plus 1 by 2, that is 3 by 2. Therefore, you can say R parallel is equal to 2 by 3 ohms. So you have calculated this entire part. So now what are you left with? So now you just have this part of the circuit. Like if I draw it again, if this is point A and if this is point B, so you had 2 ohm resistance here, the cell here, and the ammeter here, right? And now all you have is just one resistance here, and this resistance has a value of 2 by 3 ohms. This is 2 ohms. Now see, now it is very simple. So now you just have a very simple circuit for which you need to calculate the net resistance of the circuit. Now looking at this, what would be the net resistance? 2 ohms plus 2 by 3 ohms, right? So 2 plus 2 by 3, which is equal to 6 plus 2 by 3, that is 8 by 3 ohms. So this is the equivalent resistance of the circuit. And what is the potential difference? That is equal to 2 ohms. Now from Ohm's law, we know that current is equal to V by R. R here is R equivalent. So V is 2 volts and R equivalent is 8 by 3. So this is equal to 6 by 8. So 2 3s are 6, 2 4s are 8, which is equal to 3 by 4 ampere. So this is the amount of current that would flow through the circuit and therefore get measured in the ammeter. So the reading of the ammeter would be 3 by 4 ohms. Question number 20. A millivoltmeter of 25 millivolts range is to be converted into an ammeter of 25 ampere range. The value in ohms of necessary shunt will be. Now again, a quick recap. What do we do to make an ammeter? So to make an ammeter, we always need a small r in parallel. So to make an ammeter, we need a small resistance which we call as the shunt in parallel. Correct? That's what we do. Now, since shunt is a very small resistance, therefore the amount of current which will flow through the shunt will be very high. For example, let's see this. Let's say that if this is your galvanometer and you connect a very small resistance in parallel to it. This is our shunt. This is the small resistance called shunt connected in parallel. Now let's say that if I is the current which was flowing through the circuit, the moment you connect this shunt, what happens? It has a very small resistance. So most of the current will tend to flow through this, and as a result, very small amount of current will flow through this galvanometer. So in this case, the millivoltmeter which we are talking about is basically this. So very small amount of current will flow through this, and as a result, most of the current will flow through the shunt. So basically here, I1 is so small that it can be almost compared to 0 because this shunt is very small. So this route offers very less resistance to the flow of current. So obviously most of the current would like to flow through this path, right? So I minus I1 is when compared to I1 is very small. Right. So now here, if you want to calculate the value of this resistance, that is the value of the shunt, then how will you calculate that? So shunt is equal to V by I, resistance is equal to V by I, and what is the voltage? So here it says that the millivoltmeter is of 25 millivolts range. So that means the voltage across this voltmeter is 25 millivolts. So obviously between these 2 points also the voltage would be 25 millivolts. And how much is the current? Because we want to convert it into an ammeter of 25 ampere range, right? So that means we want this current I to be 25 amperes, right? And I1 is anyways very small. So this would be 25 amperes. So this becomes equal to 25 into 10 to the power minus 3 volts divided by 25. So this gets cancelled. So this is equal to 0.001 ohms. So this would be the value of the shunt. So I hope you understood. This is very large. So I1 is very small. It is almost equal to 0. So as a result, the net current passing through this would be almost I. Since I1 is 0, so we can say that I current is passing through this shunt. So we know the current passing through the shunt. We also know the potential difference between these 2 points. So it is very easy to calculate the value of shunt. So the correct option is A. Question number 21. In the circuit shown, cells A and B have negligible resistances. For VA is equal to 12 volts, R1 is equal to 500 ohms, R is equal to 100 ohms. The galvanometer shows no deflection. The value of VB is, okay. So here, first of all, let us try to see how exactly the current flows in this circuit. So let's say here you have a cell with where the potential is VA at this point. Now let's say that some amount of current I1 flows through this circuit, right? Now since the deflection in the galvanometer is 0, what does this show? That means the moment this current I1 reaches this point, there will be no current flowing through this. That is why the deflection in the galvanometer is 0, right? So the entire current I1 will actually flow through this path, correct? So basically the flow of current would be like this. From here, again, here, and then back to this point. So that is how the current flow would take place in this circuit. Now let us use Kirchhoff's loop law for this circuit. So let us call this as our circuit 1. So as per Kirchhoff's loop law, what will we do? So we will have to, the first step is to assume any direction. So let's say that we assumed this direction, in the clockwise direction. So then what happens in this particular circuit, in this circuit 1, the sum of the EMFs. So here in terms of EMF, you just have VA. So if you look at the assumed direction, it leaves from the positive terminal of the cell. So therefore VA would be positive. So VA is equal to the sum of the products of the currents flowing through the respective resistances. So one such resistance is R1, so it would be I1 R1. Whether it will be plus or minus, so you see the assumed direction and the direction of currents are the same. So this would be plus. Similarly, another resistance is R, and the amount of current flowing through R resistance is again I1. What would be the sign? So you see the current flowing again is in the same direction as the assumed direction. So this would also be plus. So this is equal to I1 into R1. What is the value of R1? In the question, the value of R1 is given as 500 ohms. and the value of R is given as 100 ohms. Right? And what is the value of VA? It is given as 12 volts. So therefore I1 is equal to 12 divided by 600, which is equal to 0.02 amperes. So this is the amount of current which is flowing through the circuit 1. Now what is happening in circuit 2? So this is circuit 2. So let's see. So in circuit 2, the entire potential difference across R is VB, right? So the sum of the EMFs in this case would be VB. Now here also let us assume one direction, correct? So let us say, so here in this circuit we assume this direction, fine. So in this case the EMF is VB and we see that the assumed direction leads from the negative terminal of the cell. So therefore VB would be negative. Okay, and what are the currents flowing through the resistances? In this case, the resistance is R and the current flowing through R is I1, because there is no current flowing through this R, right? So therefore, in this case, it is I1 into R. What would be the sign? So you see the assumed direction is like this, but the current is flowing in this direction. So the current is flowing in the opposite direction of the assumed direction. So this would also be minus. So therefore, VB will be equal to I1R. So what is the value of I1? We just calculated it as 0.02 amperes. And what is the value of R? R is given as 100 ohms. So this into 100, which is equal to 2 volts. So the value of VB is 2 volts.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.